Okay, the new topic that we're going to start today is the linked list in data structures. So let's have some introduction about the linked list. A linked list is a linear data structure where each element has a separate object. A linked list is a linear collection of data elements called nodes linked to another element by means of a pointer. So we have a linked list. You can see the last diagram in the page. Over here, I mentioned starting as a head. Head means the starting point, and it is having some particular address over here. Let me change the address over here so that no difficulty over here. I change the address from 21 to 01. Yes, much better. So head means it's having the address of the first node. At which address the first node is saved. So head is having the address 109.801. It means that this is the address part. This address part is having this particular linked list. So head means it stores the address of the very first element from where the linked list starts. So the linked list is a linear collection of data elements called nodes linked to another by means of a pointer. So you can check it over here that each node divides into two parts. One is 22 and one is a big number. That big number is address. Fine. Each node is divided into two parts. First part contains the information of the element. So 22 is the information of the first node. 22 is the information of first node. The second part contains the address of the next node in the linked list. So this 109821 is the address of the next node. You can check over here. The next node is having address 109821. If I want to make it more clear, so I will explain you with the help of you can check it over here that this represents the address of this one, and this represents address of this one, and this represents address of this one, and this represents address of this one. Fine. Let me start again. That each node is divided into two parts. First part is the information part. We call it as 22 as information. I again want to make some changes over here so that you can understand easily. So I write over here information. So what information? That this 22 is, we call it as the information. 22 is the information. Fine. And the second part is the address of next node. So again, I write over here address of next node. In fact, node. So in fact, an ODE node. So this 109821 will become the address of next node. So you can see it over here that each node is divided into two parts. The first part, that's 22. 22 is we call it as the information part. I write over the information. And the second part contains the address of next node. So this part holds the address of next node. So this one is the address of the node that we are currently running. Fine. So every node has two parts. First part was the address of the information about that node. Second part was the address of the next node. Fine. So this is one node with 22 and 109821. So again, a linked list is a linear data structure where each element is a separate object. A linked list is a linear collection of data elements called nodes linked to another by means of a pointer. Pointer means address of the node. Each node is divided into two parts. The first part contains the information. 22 becomes the information of the first node. And the second part contains the address of the next node. In the linked list, this 109821 is the address of the next node. This is the next node. And the first node is linked to the address node that is stored on this particular location of the address. The last node in the linked list uh, has a reference or address null. You can see the last node. This is the last node. Says no further node over here. It means this address become null. It means that after last node, there is no further node in the linked list. The entry point into the linked list is called head or start. So entry point, this one, we call it as a head, or we can call it as a start, which is the starting point, which is the head point with the particular address. It should be noted that head is not a separate node, but reference to the first node. So what head is? Head is basically a address that specifies as from where the linked list starts. So the head specifies the address. That address shows that the node at location 109801 is the first node of the linked list. If the list is empty, then head is null. So if there's nothing in the linked list, the head will have value null. That nothing is in the linked list. Linked list is that a linked list consists of two parts. First is the information part, second is the address part. So this figure represents a linked list in which the first head represents address of first node, and the first node have two parts, one information, one address. 22 become the information, and 109821 is the address of the next node. Similarly, node number 2, 57 become information, and 109811 become the address of next node. In third node, 8 become information, 109833 become the address of next node. In the fourth node, 69 become the information, and null. Null means there is no further node in the linked list. This is what a linked list is, how does it works. So head, that item, next, again, next node, that item, next, again, next node, that item, next. If it is null, we write over here, null over here. A linked list is a linear dynamic data structure. Why dynamic? Because we can increase or decrease the size of the linked list during the execution of it. So the number of nodes in the list is not fixed. We can grow and shrink as per demand. So the number of nodes in the linked list are not fixed. So we can increase the size of linked list. We can decrease the size of the linked list as per our demand. Any application which has a deal with unknown number of objects will need to use the linked list. So an application in which we are not clear that how many elements we have to use in it. So if we are unclear of it, then we go for the linked list. Because when you are not clear how many elements we are going to use, then you go for better option is go for linked list. Linked list does not allow direct access to individual elements. You cannot access any element by yourself. You can access only that element whose address is mentioned in your node. If you want to access a particular item, then you have to start at the head and follow the references until you get to that item. So let's go back. If I want to say that I want to access the element at location 109811, I cannot directly go to over here. I have to go through the first node, then the second node, then I reach over the third node that is on the address 109811. So it means I cannot directly reach that particular node. I have to go to a particular path. If you want to access the particular item, then you have to start at the head and follow the reference until you get that item. Linked list used more memory compared to any array because we are using the two options over here. One is the information, one is the address. So we extra 4 extra bytes are being stored in the address of the next. So this is the type of the linked list. One is simple linked list, W linked list, and circular linked list. So there are 3 types of linked list. One is the simple, one is the W, and one is the circular linked list. So we do all the linked lists one by one. We start with the simple linked list, or you can say linear linked list. So what are the various operations that we can perform on a linked list are? Insertion, that we can add a new element in the linked list at any location, either at the starting, either at the end, or in between any location in the linked list. If you remember, when we did the stack means we can insert element at top of stack. When we did queue means we can insert element at the end of stack, sorry, end of queue, and we cannot insert element at any particular location in stack or queue. But in case of linked list, we can insert the element at any location, either in the starting or in the end or in the in between the linked list. Delete again, you can delete the element from first location, from last location, or you can delete any element from anywhere in between the linked list. If you remember, when we did stack and queue, in stack we can delete the element that's on the top. In queue we can delete the element which is on the starting, and we cannot delete the element from any location in stack and queue. Whereas in case of linked list, we can delete the element at any location in the linked list, either in the first or in the last or anywhere in between the linked list. So display means we have to display all the contents of the linked list that we have, how many number of nodes are there. And search means that we want to search some particular element in the linked list, at which location that element is in the linked list. So insertion, deletion, display, and search are the four operations that we can perform on the linked list. Linked list is, so insertion operation, adding a new node in the linked list is more than one step activity. First, create a new node using the same structure. Find the location where it has to be inserted. Link the node specific location to new node, and the new node is linked to the node to a specific location. So if we want to insert an element in a linked list, it's not a single step as in case of stack and queue. First we have to create one node. That node have information and address part. Then find the location, at which location you have insert that particular node. Then link the node to a specific location to the new location. So we have to mark the address, which is the next location, or which is the next node ahead of that particular node that we have added in the linked list. We are having a linked list that is data element 1, data element 2, data element 3. Only 3 elements are there in the linked list. I want to add one new element in the linked list, that's that item. So first I create a node. After creating a node, I find the location. That location number 2, I want to add the new node. So previous node get the address of this node, and this node will get the address of next node. Well, these are the changes we have to make whenever we have to insert an element in the linked list. It means various changes are being done whenever we insert the element in the linked list. So we want to insert the element at second location. We find the location. This node is added over here. It means the node previous to it, earlier this node was attached to this one. It means here we have address of this one, but now we insert this node. This address changes from this one to this one. So this address we get now address of this particular node, and this node have address of this node. So this is how the changes have to be done over here. Let me explain how it can be done. If we go back, okay, I will copy of it. I will copy of it. I have pasted it over here. Okay, this is a node, and let's say the address of the node is I changed from here to this one. Fine, and the value over here I change it to 80. Fine. So I want to add this node at location number 2. It means the location number 1 value get changed from this one to 40. Fine. It means if we select this one arrow, Okay, I never select it, so I pick up over here. This will get attached to this one. Fine. So this will get attached to this one. So this is address over here, and this address is what 109821. So I write over here 21. So it means this node will attach to, at which location? This will attach over here. Right? This is how we can do it. If I want to insert the second element, in fact, I have insert over here, so I change the value from here to okay. At this location, the element is inserted now. Fine. So these are the changes. It means huge changes have to be made whenever we have to insert an element in the linked list. Fine. So create a node, find the location, and change the address of previous as well as next node. These are how we can insert the element in the linked list. So insertion, if you want to insert the element at the beginning of the linked list, I want to insert the element that is on the first location of the linked list. In this algorithm, a new node is inserted at the beginning of linked list. A linked list is being pointed by a pointer head. Every linked list has a pointer, that's a head. If avail list is have empty node, insertion can be done. Avail is a list that represents that how many empty nodes we have. If there is no node in the avail list, we cannot insert. If avail list is empty, no space is available, overflow the message. Let's take example. You are sitting in a room, 5 chairs are there. So 5 people are sitting over there. And you enter the room, you are 6 person. The host asks the attendant to go and bring one empty chair. The PM will go to the room from where he has to bring the empty chair. If no empty chair is there, you cannot sit. Then the host will say the room is full, kindly come after some time. So this is what the avail is. So if no empty space is available in the linked list, then we got a message of overflow that the linked list is full, no empty space is there. So overflow will be displayed. So I'll go to add a new element as starting of the linked list. INFIRST is the name of the algorithm. Information is the data in the algorithm. A link is the address of next element in the linked list. Avail is a collection of empty space, and item is a new data item I want to add in the linked list. So every algorithm start from start. If avail is equal to null, there's no empty space in the linked list. So print overflow, no empty space available. Exit from the program. Else, set new is equal to avail. So I pick one node from the avail linked list and I call it as a new. That node we call as a new. Remove the first node from the avail linked list. Whatever the node at first the avail linked list, I pick it from there and set avail is equal to link of avail. It means if I pick the first element from the linked list, the first element is removed from the avail. Now second element become the first element in avail. Second element become first element in avail. And I write over there info of new. What is new? New is the new node. New is the new node. In information part of the new, I write the item, whatever item I want to insert, and link the new node to start. Whatever value is given in start, that value is now address of the new node. And set start is equal to new. Now the start will have the address of the new node and stop. Let's see how it works. I'm having a linked list, this 109801, in which I'm having 4 elements over here. I'm having 4 elements over here. So, okay, this is avail. This is what? This is avail list. It means 3 availabilities are there. I can insert 3 more elements in my linked list because 3 nodes are having an empty space for the information. Fine. New is equal to avail. So new means new will become this 20014. This is empty space in avail. I call it as a new, and later on this avail was having address of 200.200.114. I pick this one over here. Now avail will become 200.27, and avail start having only two empty addresses. Fine. uh, Let me explain. So avail having the three empty spaces, I pick one empty space, call it as a new, and now having remaining two availabilities in avail linked list. Okay, because I have want to add the new element at the starting of the linked list. So I am having a linked list having four elements: 22, 57, 8, and 69. You can see over here the value of head is 1098. In fact, I write over here 01, 01 over here, because 01 is address over here. Fine. So I change it over here so that no problem come on your side. This become 01. Fine. Uh, Again, start from here. Okay. I'm having four elements in the linked list: 22, 57, 8, and 69. Head having the value 109801. This is the first element. And I want to insert the new element at the beginning of the starting of the linked list. So it means I have to add an element ahead of 22. So I add the element having item part, having address part. And you can see over here the head information get changed. The address of first element get changed because I have added a new element at starting of the linked list. That element I picked from there now is become starting. As is the first node, it means the value of head get changed from 109801 to 20014. Now this becomes the first node. If this is the first node, then this becomes second node. So I write over here 109801. That is the address of next node. So second node is this one. So this is how I can insert the new element over here, and information part of new become item, and link of new become start. You can see over here start value was how much? 109801. So link of new become 109801. This become whatever address is in the start or head, that will become the address of the first. And item is the whatever value you write in the item, that value will come over here. This is how I can insert a new element in the linked list. So second algorithm is that we want to insert the new element at the end of the linked list. So you can see over here, I'm having algorithm that is INSEND. Data, next, new node, temp are some of the important variables that I have used over here. So INSEND is the name of the algorithm. Data is the new element inserted in the linked list. Next shows the next node address. New node is the new data and address to be added in the linked list, and temp is the temporary pointer that holds the node address. So let's start over here. Our algorithm always starts from start. So read new data. So whatever the data you want to enter, you just give some value of the data. If avail is equal to null, if there is no empty space, it means overflow. I cannot add anything new in the linked list and get out of the program. That means get out of the program, but you can do nothing over there. If some empty spaces are there, so what I do is I call that new node is equal to avail. It means the first node in the avail list, I select it and give the name it as a new node. And avail is equal to link avail. It means now the starting address of the avail list will be having address of second node of the avail, and new node is equal of data become data. So whatever data user enter over there, that become data of new node. And new node next, because we are adding the element at the end of the linked list, it means the next element there is nothing over there. We are adding that at the last, it means the next element of that node will have value null, because we are ending at the end of inserting at the end of the linked list. And set start is equal to no node, else temp is equal to start. So we keep on finding what location we have to add it over there. So what we have to do is let me check over here. Okay, so initially we have no slide over here for the end of the linked list. So in just assume this one, that I want to add this element at the end of the linked list. So what will happen? Uh, let's take the example of this one that I want to add into the end of the linked list. So this will come over here. Fine. This will come over here. I remove this null from here. This will have the address of this node, that is 20014. That now this having address, next node address is this one. Fine. And this is the new node here. So I remove it. I remove it. I remove this one also. I remove this one also, and I remove this one also. So after this node, I added this one node. Now this, because this is the last node, after this node, there's no node. So I write over here NULL. That means this become the last node of the linked list. Earlier linked list was having 4 nodes. Now it is having 5 nodes. First node, start this head will remain as the same. That is the 109801. Starting of the node is this one. Node starts from here. This is the first node, information 22. Next address is 109801. This is the second node. Information is 57. And address is 109811. That's the address of this node. Third node is having well information 8. And address part is 109833. That's the address of this node. And this node having information 69. And the address is 20014. That's the address of this node. And whatever value user will enter, let's say if I enter the value 55, then this become the value I have added over there. Because this is the end of the linked list, so it will become null over here. So we cannot insert value over here because this is the last item of the linked list. So this is how we can insert the element at the end of the linked list. What I have to do if I want to insert the element at any particular location. So I don't want to insert as starting. I do not want to insert at the end of the linked list, but I want to insert in between the linked list. So what the algorithm is INSPOS, info, link, start, avail, item, position. So these all are the important variables, parameters I have used in my algorithm. INPOS is the name of the algorithm. Information save the data of the current node. Link save the address of next node. Start save the address of the first node. Avail empty node from the avail linked list. Avail is the linked list that having the empty nodes. Item is the new data that I have to insert in the linked list. POS is the position or location where I want to insert the element. At which location I want to insert the element. Let list be a pointer in the linked list. In this algorithm, node X inserted. So let's start over here. Input the new item in the linked list. Input the location POS where you want to add the new element. So item means that you enter some value, that value become the item, that this item I want to add as a information part of the new node. And position means at what position you want to insert, second, third, fourth, six, whatever it is. But not first, not last, but in between anything. So the position will be having value either 2, 3, 4. So I cannot write the value of POS as 1. I cannot write the value of previous as null because I want to insert at any location. So set k is equal to 1. K is a variable, initialize value 1, and set temp is equal to start. So temp is a variable who's having a value start, that from which location the linked list starts. Let the write a loop over here. Start the loop over here. Loop repeat while k is less than the position. So initially value of k is 1. So position is value 2, 3, 4, whatever, what position you want to insert. Set temp is equal to temp of next. So initially temp is start. Temp equal to temp of next means that the value of temp will become the address of next element. If temp is equal to null, it means this is the last node. The node in the linked list are less than position. So and exit up from there, and exit from there we cannot insert over there. Else k is equal to k plus 1, we move to the next one step ahead. हम एक step आगे चले गए. तो जौन सा ये नंबर 4 से लेके नंबर 10 तक चल रहा है काम, ये काम चल रहा है ढूंढने के लिए कि हमने जो सी लोकेशन एंटर किया क्या वो लोकेशन हमें मिल गई है कि नहीं मिली. वो लोकेशन ढूंढने के लिए हम जो है स्टेप नंबर 4 से लेके स्टेप नंबर 8 तक का हमने चलाया ये काम सारा. सो ये लूप चलती रहेगी टू फाइंड द लोकेशन. जौन सी लोकेशन की वैल्यू हमने लिखी है कि वो लोकेशन वैलिड है भी कि नहीं वैलिड है. ठीक है. सो द फ्रॉम स्टेप नंबर 5 टू स्टेप नंबर 9 वी फाइंड द लोकेशन. जब हमें लोकेशन मिल जाएगी, व्हेन वी फाइंड द लोकेशन, set avail is equal to null, then overflow. अगर हमारे पास खाली स्पेस नहीं है, इसका मतलब overflow हम कुछ भी ऐड नहीं कर सकते. else new node is equal to avail. हमने एक नया एलिमेंट को वैल्यू, न्यू नोड क्या है उसको हमने दे दिया avail. नया नोड है उसको हमने नाम दे दिया new node. and set avail is equal to link of avail. और जो चीज़ अवेलेबिलिटी है उसका लिंक करेंगे हम अवेल के साथ. इसका मतलब अवेलेबिलिटी मीन्स जो पहला एलिमेंट था अवेल में वो पहला, अब वो अवेल का सेकंड एलिमेंट अवेल का फर्स्ट एलिमेंट हो जाएगा. एंड न्यू नोड इज इक्वल टू और डाटा बिकम इंफॉर्मेशन. जो भी इंफॉर्मेशन आपने एंटर की थी वो उसका न्यू नोड किया वो इंफॉर्मेशन बन गया. एंड न्यू नोड ऑफ नेक्स्ट इज इक्वल टू टेम्प ऑफ नेक्स्ट. सो वी फाइंड द लोकेशन एट विच लोकेशन वी हैव टू ऐड. सो वो न्यू नोड का लोकेशन क्या, टेम्प ऑफ का नया लोकेशन बन गया. एंड temp of next is equal to new node. So what this means that let's take this example over here. Earlier we having 1 2 3 4 nodes are over here in my linked list. So I can either insert value 2 or 3. So because 22 first, this is the first location, this is the last location. So I want to insert either in location number 2 or location number 3, just become the in between. Okay, if I write over here location 5, it will become last location. So 2 3 4 any value can be inserted over this. So in availability I am having 3 availabilities that I can add 3 more nodes in my linked list. New is equal to avail. So the new node get the name of avail, and avail is equal to link avail. Mean earlier we having the 3 nodes in the availability. I have used 1. I am left with only 2. So this second node will become now first node on the avail list. Okay. So in this slide we check our linked list, we check the availability, we pick one node from the availability, and earlier avail was having 3, now avail left with 2. So this slide shows us that I have selected one empty chair from the room holding the empty chairs. So add the node at third position. So I entered the position third, that I want to add the node at third position. So the k is equal to 1 and temp is equal to, here you can see temp is equal to start. Temp is equal to start means this is a starting point. Whatever address is over here, the address become address of temp. And k is equal to 1, temp is equal to temp of next. This is the next element of it. I move over here and k become 2. again temp equal next, I move over here. So here the value of k become 3. So I stop over here because I want to add location number 3. I stop over here. So I add the new element k is equal to 3. Add the new element over here. Okay, and temp is equal to temp of next. So this value, this is the new node, and here the value gets changed. You can see over here that temp of next is equal to new node. Temp of next, uh, temp of next is equal to new node. This is address of new node that come on the temp of next, and this is the new node, and you can see over here new node next is equal to temp of next, and temp of next was 109811. Now this become the new node add of this new node. So item is whatever item you entered over here. So this is how we can add the new element at the third location in the linked list. So it means when the k become 3, I stop over there and I insert the new element over here. I change the value of the previous node address and the change the value of current node address. So the previous node address will become the address of new node, and the next node that is attached to the new node will be the node this one. So this is how I can add the new element in between the location in the linked list. So this is all about the insertion, that how can I insert the new element in the linked list at any location.